Okay, so we did examples 1, 2, and 3 using our TI-84. Okay, so we just did it using our TI-84s. Now we're going to talk about how to do this. If I don't have a TI-84 with me, what can I do? Well, don't worry. We're going to model it for you with using DESMOS. So here we have 2x to the 4th plus x cubed minus 3x squared. So I'm going to open my DESMOS calculator. I did put the link on your Canvas. So you do have the link on there. So on here, I'm going to put in my 2x. I'm trying to make it a little bit smaller. Scoochy scooch there. Okay, it doesn't want to let me to be great right now, guys. Maybe I could scooch just a smidge so you can see everything. Okay, there we go. Okay. I don't know why it's playing these games with me, but it's like, nope, not today. There we go. So we have 2x to the 4th plus x to the 3rd minus 3x squared. Okay, so this is what our graph ends up looking like. Okay, on DESMOS, there isn't any left or right. It's just literally going to tell you where the points are. You click them and it'll hold them where they are. So now you have your points of increase and decrease. So not your points, but you have your values of where it takes place. So as you can see here, we have our maximums and our minimums and our max and min points. The grammar of it all. Okay, so with that, I'm going to write out what I have and pull the information that I need from here and keep it going. So for our first values, it's going to go away. So you just got to either trust it or look at along with me. So we have 1, 2, 2 minimum values. So we have a min value, and that point is going to be -1 and 74 thousandths, comma, -2 and 38 hundredths. Okay, now our minimum point is this, but this guy is our minimum value. Remember, your y is the value. The other min value that we had was at 0.699 and -0.0647. Oh, no, it wasn't that. Ignore this 0. I can't get to my eraser for some reason. So that's where that was at. Okay, again, this is our value. This is the point, but when it's asking for the value, all you're telling me is the y, okay? Then we had our max value was located at the following point. It was located at the origin, 0, 0. And again, that puts the value here. Okay, remember, these are all relative or local max and minimums, so they're not going to be our absolute necessarily. But in this case, we do have what's called an absolute. Our absolute, let's go back to our graph really quick. This guy is our absolute minimum because it's our lowest point of all, right? So this would be called our absolute. It's not just our relative local, it's our absolute minimum, okay? So this guy is special. This is where our absolute is, okay? All right, so now that we've done that, oh, look, now my eraser wants to appear. There we go. I'm gonna fix that up a little bit. There we go. Now we're going to talk about our intervals of increase and decrease. So where are we increasing and decreasing from? So if we remember our graph, I'm going to do a little sketch of it. It goes like this. And it went like this. And it went like that, right? This is what the Cortic did. So we had boom, boom, boom. Okay. So we are decreasing from negative infinity up until this point. Remember, your intervals are using your x values to describe. So our first one would be here. So we are decreasing And we're decreasing from negative infinity until we reach the x value here. And that x value is there, -1 and 74 thousandths. Okay. Then from here to here, we are increasing. So we're increasing. And again, what are the x values from this point to that point? So the first x value is still going to be -1 and 74 thousandths. Then the next x value is going to be 699 thousandths. That's our increase. And then we do another decrease from this point to this point. Again, focusing only on the x values. So we decrease from this x value, which is at 0.69. And no, it was not 0.69, guys. It was 0, the origin. Silly me. I'm sorry. Pretend you heard nothing. Without the graph, I was trying to wing it. This is 0, and then this is 0.69. So we go to 0, and then from 0, we go to 0.699. If we were all together, you're all like, Miss James, no, right? And then from here to infinity and beyond, we're increasing. So then we're increasing from 0.699 to infinity, okay? So that's how it would work using DESMOS as your aid to show those levels of increase and decrease, okay? You can totally do it there. It'll get the job done, and it does the same thing. But notice how I did decrease and increase from left to right. You can separate, make the column. But for me to stay in order, it helps for me to go from left to right, okay? All right, and again, notice that intervals of increase and decrease are all strictly based on your x values. This is where you're using your x values, okay? And you're gonna always use parentheses, okay? You're just telling me where it's increasing and decreasing, not where it's equal at. So we're not gonna have any brackets. We're gonna just have parentheses all the way through. All right. The other thing is that these can be written in interval notation. So in interval notation, this would be written, this is written in interval. It could be written in inequality notation. So this is saying I am decreasing when my x values are less than -1 and 74 thousandths. This is saying I am increasing from -1 and 0.4 to 0, right? This is saying I am decreasing from 0 to 699 thousandths. This is saying I am increasing when x's are greater than 699 thousandths, okay? So be comfortable seeing it also in inequality. All right, okay, that's it.